Okay, the background on this talk is that I have been analyzing and re-engineering old softwares for the last 25 years, and I've suffered terribly under the sins of the programmers. So the quintessence of my talk is I want to have a new law, UI Turbine. I know you already have lots of new laws with the current regime, some good, maybe some not so good, but I have an idea for a new law, which add on to the other ones, and you will see what it is at the end. Okay, wait, doesn't go. Yeah, turn it on me. Oh, the other, yeah, okay, now. So what is technical debt? That's the subject of my talk. I know you want to go to lunch soon, so I'll go through quickly. This term was coined by Ward Cunningham back in 1992 at an Uppsala conference, implying all that is not right with the code, which we put off to do later. Originally, the inner quality of the code was meant what the programmer had done wrong in the program code, but later it was expanded to include also what he left out. In the book Managing Software Debt, Building for Inevitable Change, Sterling sees in technical debt the opposite of sustainability, namely everything which is postponed for later, which goes into the backlog, so to say. So we all dread financial debt. You are familiar with financial debt in Hungary from the IMS. And so what about technical debt? Ward Cunningham used this term to describe roughly what makes future more difficult. And later, Martin Fowler defined technical debt as like financial debt. It incurs interest payments. You see, you have to pay the commot, and this accumulates, which comes in the form of extra effort that we have to do in the future development. So we can choose to continue paying the interest, or we can work to reduce the amount of debt and also reduce the interest. This is the issue in the United States, today, that the government is spending more and more money than they don't have, so they have to borrow it somewhere, from the Chinese, for instance. So the metaphor also explains why it may be sensible to do the quick and dirty approach. Just as a business, we live from day to day. Most people are only interested in surviving the current day. And what happens tomorrow or the day after tomorrow doesn't interest them. So they're all too interested in a current market opportunity, and they're putting off the problems into the future. So the debt incurs. The software gets worse. The more the developers deal with it, the worse it gets. Clones, redundant code, long methods, short names, deeply nested logic, shotgun surgery, all of this, you cannot believe how bad software is. So as I say, the last 25 years, I'm traveling around Switzerland, Germany, Austria, Hungary. Well, and I haven't seen so much software from the Hungarian companies, but from the German-speaking countries, it's really bad. And it doesn't depend on the language. It doesn't matter whether it was in assembler or in COBOL or in Java. It's bad because the programmers just don't give a damn. That's the problem. They program something to get it out the door and forget about it. So technical debt is the sum of all those things that should have been done and never were. So the debt is growing proportional to the amount of software which is being put into the world. And of course, the Agile development is accelerating this software growth. The problem is you never get something for nothing. There's no free lunch. So the price for rapid delivery in Agile development is technical debt. This is the shadow side of the Agile development, which it always existed even before Agile development. We had the same bad software. But now it increases. Projects take on debts to deliver the next release on time and in budget. Features and quality attributes not essential are postponed until the next release. So you know damn well if you're a programmer and you have to ship at the end of the month, you have to deliver the software, and you will be judged on whether you keep this deadline or not. So what will you do? You will cheat. You cheat. You leave out security checks. You leave out exception condition handling and this and that. What you know that the product owner will not notice because he's only going to look at the software superficially and say, oh, it looks nice. Yeah, but what's going on behind the screen, he doesn't know. And the postponed features and qualities accumulate in the project backlog. But like all debt, like also the national debt in America, it has to be paid back someday. So the Agile concept is used to justify the production of more and more redundant software, which we should not be building in the first place. It's not possible for every company in the world to build their own individual software. They have to get over this and start using standard software and standard web services because we cannot afford to keep going on and accumulating more software and a higher technical debt. The Agile teams have hardly any time to go back and correct what they've done wrong, the structural and architectural deficiencies, let alone the many code deficiencies that they make. So a survey of IT users in the US showed the average technical application or business application is burdened with a technical debt of $2 million US. Gartner estimates, and you can look up these sources in the Gartner report, the technical debt in the IT sector of America is already greater than $500 billion and is approaching the sum of $1 trillion US in the year 2015. So the following subjects have to be addressed. Continual measurement of technical debt should be done to control the total cost of maintaining the current software during the entire life cycle, and we have to look at this over a 30-year period. Right this day, I'm working on an old assembler system which has been in operation for 30 years, and it need not be in the terrible condition that's in today, but it was neglected, yeah? So inclusion of technical debt measurement in the release of a product, monitoring the costs of technical debt, and we must foresee for regular cleanup periods where we stop the rapid development and go back and refactor. So the causes of technical debt we see here, one side is incompleteness, things that are left out. The code is incomplete, documentation is missing. If you go to a company to look at their software, you hardly ever find an up-to-date design model. No design model. The requirement documentation was last updated 5 years ago. So what do you find? Only the code and the heads of the people who think they know what the software does, but who have often long forgotten it, missing code features, the documents incomplete, test cases that were made and never executed, missing error handling, and no security checks. This is the one side, what is left out. The other side is what the programmers do wrong: deficient code, defective documents, inconsistent documents, badly structured, non-uniform code, lack of conformance to standards, and so forth. So I've given you here some samples of incompleteness. Mostly it's lacking security checks, no exception handling. When they call remote procedures somewhere, they assume most of the time it will be okay, yeah, so they don't check the result, what comes back. Missing recovery procedures, no comments, why? That just takes a lot of time to write. No assertions to check the correctness of their code. Missing integrity rules and help functions, and so forth and so on. Samples of sloppiness, simple sloppiness, because programmers really don't care. They don't care. If programmers are good, they become a professor. and stay at the university. If they don't make that, then they become a consultant somewhere, you see. And if they don't like that, then they can always be a manager, but they don't stay in programming. So the result is that the deadbeats of the IT world, those who can't do anything else, they remain in the programming down at the development level, and they make all these bad things here. So too deeply nested control flow logic, cloned code blocks, different names for the same variables. At one point, they lose the overview of their software and they get all entangled in this naming bit. Hard-coded data constants is one of my pet peeves. I've seen software in Vienna where they even put the bank accounts of people hard-coded into the code. Inconsistent interfaces, names that the model don't match to the names in the code, maybe they don't even match to the other names in the model, and code functions which can no longer be traced back to the requirement. There's no way to find them in the requirement. So this is a sample of some software that I've measured. It's a .NET system, and what you see here are the hours that it will take to correct each of these deficiencies here, such as data casting, or missing final clause, class not derived from a superclass, I/O operations not in a try block. So you try to estimate what it costs to clean up each deficiency, each smell, you might say, and then you add them up, and then you find that this system here has a total correction effort of 14,443 hours. That is the sum of the technical debt. Now, one of the responsibilities of the user is to try and reduce this debt, and this graph here is showing how the debt is decreasing through renovation. From release to release, you try to reduce it from, say, here, 0.225 was the percentage relative to the development costs, then back to 0.03. So this is what you should be doing. I'm showing you here how to measure it. This is the measuring the debt relative to the principal, to the value of the total system. How much of the total system is the technical debt? What you see here is the debt is 1 minus the current quality over the quality that should be in, what you're striving for. So Bill Curtis from Texas, CAS Software, has given this estimate here. He says technical debt is reduced when you add the missing features, remove code and document deficiencies. So you compute it as the effort to add missing features plus the effort to remove the smells, the coding deficiencies, times the hourly rate. And he comes here to a debt per statement. I came to a debt per statement in this .NET system. This was the sum of all the statements, 215,000, and this is the debt per statement is €5.72. And in the Computer Weekly, Bill Curtis published an article in the US that the average debt per statement there is $3.61. So this system here is particularly bad. So what is the role of the tester in an agile development? The tester has a very important role because the tester is not only responsible for testing, running the acceptance test, but he should also check the unit test results. He has to make sure that the developers are doing their job. They have to protocol with JUnit, their unit tests. He has to check them. The source code has to be analyzed. There are lots of tools for doing this now, you see. The software sonar and so forth. The system model, the UML has to be checked and guarded. And the user stories also have to be examined, that they are done properly. So the tester collects and checks all the software artifacts. This here just shows some of the possible checks that can be made alone in source code. comparing the content of the code with the content of the user story, comparing the code with the coding convention, comparing the code with previous versions to see if the complexity is increasing or the quality is decreasing, and human inspection. Of course, the tester can't check all the code, but he can make spot checks. In addition, we should have in Agile projects a so-called project tracker. Linda Crispin wrote in her book on the Agile testing, the tester should not be forced to take on this role as project tracker. You need an additional tracker here who keeps track of the time, effort, cost, and is continually measuring the technical debt based on what he gets from the tester here, the defects and deficiencies. So this was my first manager when I started programming in the US Navy Department, John Shore. He wrote an article called Confessions of a Lapsed Software Engineer, or Why I Never Met a Programmer I Could Trust. It is not that software developers don't believe in quality, just like people say also they're religious. They believe in religion, believe in God, but under pressure, they cannot resist the temptation to cheat. Yeah? So if they have a hard deadline, they find a shortcut. They are simple sinners, you see, and you handle simple sinners in America with the threat of punishment, you know, purgatory, fire and brimstone if they perform badly. So his theory was software developers must be responsible for their sins, yeah, Fehlerlöschung. And that's where I get to my law, the Sabotage-Termin. Yeah, we make contractors with the programmers, you see here. They get a base pay, yeah, let's say 300,000 forint a month. So they won't be a Hoylektalan here and litter the streets, so at least they get that. The rest of the pay is based on their performance. So they can earn the full amount, let's say 1 million forint a month, if they don't leave any technical debt. But for all the technical debt they leave behind, it's subtracted from their salary. The team agrees to pay for the debt they incur. So I have these young people at the university. They love this Agile and no management. They manage themselves. You see, that's great. Freedom, programmers free at last. But free people must accept the responsibility for their actions. And that applies to programmers as well. So programmers must be made liable for what they do and what they don't do. Yeah? So that's the quintessence of my talk and why we need this new law, yeah? Sabotage-Termin for IT developers. They must be responsible for their debt. Agile development must be accompanied by rigid control and harsh punishment. It's the only way to really make people work right. Agile team can manage itself, but it must bear responsibility. The team should be liable for the debt they leave behind. Either the team works at its own cost to reduce the technical debt, that's I mean they come back on the weekend to clean up their mess. The software developers must learn to take responsibility, and professional software development is not a game. Software Fehlerlöschung Nemjatik. Yo, that was it. So, thank you.
Great presentation. Thank you, Ryan. Any questions?
Oh, they throw tomatoes at me.
I've been working in testing for more than 12 years now, and my experience is, unfortunately, I have to tell that testers are not respected as much as developers in general. some companies even developers belong to a higher grade, pay grade than testers. I've had that experience in some companies as well. So it's very hard to say that a tester has to review a code or has to keep some kind of review on a developer's code when you are not expected as a tester. As a developer, especially in Agile, it very much reveals, Agile in a Scrum mode, working in a Scrum mode, who is the best one, in the team.
Yeah.
So who is better, who is least as good, And when I want to review as a tester in a team, a developer, a respected developer's code, the developer won't listen to it. Only to another developer who he thinks that is on the same scale. So I don't know. It's really. I do agree with you. Your presentation is absolutely right, absolutely good, and I do agree. It's just very hard to, as you said, enforcing the discipline. That's my experience. So do you have some experience how to really make this deal work? Maybe you can tell something.
I think the tester should have a higher qualification than the developers. I think every tester in an agile team must be able to read and understand code. And we have this in the Onicon now. We used to hire people off the street to be testers. Anyone could be a tester. They have to have a programming language now to enter the company as a tester. Now, you will notice that in my talk, I didn't say anything about errors. You see, I said things that programmers leave out and things they do wrong in the code. If they make an error, we don't punish them for making errors. What we punish them for is sloppiness and not adhering to conformance standards, you see. So this is what leads to technical debt, and it's not the errors. So the tester has to have enough knowledge and experience, skills, to be able to recognize these things in the code. I mean, if a tool can recognize that the try and catch is missing on a remote procedure call, the tester can notice that. Many of these things are detected automatically by tools. And the tester can see that the comments are there. The tester can see if a function has been programmed or not. It's either in the code or it's not. Yeah? So I think we have to train the testers better. Well, my answer to your question. Testers must be better trained. Testers must be equal partners in the Agile development project. And a year or two ago, I published an article in the Professional Tester that tester-driven Agile development. The testers should be, driving the project even, and not the developers. Right? So next to the user owner, there's a tester, his main partner in this, and together they drive the development.
Okay, next one.
Thank you for this very interesting presentation. One remark. I think one of the main reasons of technical debt is the lack of knowledge about the code of the programmers, because programmers are using the so-called Sneed method, and this doesn't lead to a total mental model of the code, and therefore the errors are proliferating.
Yeah.
So,
Okay, but you yourself have a tool for controlling these things, you see. And the question is, why are these tools not used? Why not? Yeah. Question.
I think the argument of punishing people for technical debt is greatly flawed, in my opinion. If we take that to the nth degree, then I think surely the technical debt that goes into production, then the testers should be punished because they've missed those aspects. Now, going back to one of your points about the developers, I absolutely agree that they make mistakes because they're under pressure.
Yeah.
So surely the people that need to be punished are the managers who make them under pressure.
Wait, Lloyd.
Going back to your analogy of the US debt, it's the poor, humble people that have to pay that debt.
Yeah.
Surely it should be the governments and the people in power should be paying back that debt.
Yeah, okay, but let me say this. I do not want to punish programmers for making errors. I make a distinct difference between making an error and purposely nesting the code too deep, yeah, using wrong names. Most of the technical debt is on purpose. They know damn well what they're doing when they write the code and write it wrong or leaving out the comments where they should be. Yeah? So there's this thing of making errors, incidental quality where they make errors, and the other is where intentionally things are left out or done wrong in order to get faster. But you're right, the tester should catch this. Yeah.
Just to come back on that, I'm sorry, I know many developers, and I don't think they come to work intentionally of putting things in to make things harder for us.
I don't know any other reason how the code gets in this terrible condition. It's done intentionally. Yeah. Yeah.
Question? Okay, final one before lunch.
I want to point out a little bit, why are you really caring about technical debt that much? It might sound weird, but well, if my competitor has the same technical debt than me, I only need to have a little bit less technical debt.
This is exactly the argument of the Obama supporters in America. They say it doesn't matter. The others also have debt. Yeah.
So why are you not caring on the other side, like the other said, on the requirement side, clear requirements and know what to do, don't put pressure on people, don't punish them, motivate them and praise them for good work, and try to do business value instead of avoiding debt.
Yeah.
Because I think that's the way to go. If you see it, then companies around here. So why are you not caring about business value? Why are you caring that much about business value?
Okay, because that's the other side of the coin. And the company is often forced to choose between business value, time to market, immediate delivery, or accumulation of technical debt. It's a trade-off situation. You're right. It could be that the emphasis in one project is on rapid delivery, and the other project it's on sustainability. Yeah. You have to make choices. Yeah.
Okay,
Mhm.
thank you very
Yeah.
much. Again, Harry?
I hope I didn't provoke you too much. Yeah.
Yeah,